video. It's now question 1D of 2009. We got the long journey, the long journey. So we have a plus minus n at the end, and we need to find the smallest n for which this sum exceeds 100. So let's calculate partial sums. 1 minus 1, 2 minus 2, 3 minus 3. And when you get the positive numbers, and the odd number spots. So it's at the 100th odd number. 2n minus 1, 2 times 100 minus 1 equals to 199. And at spot 199, we actually have 100. And surprise, surprise, the max module code that I'm taking has the module code 199. Interesting, right? Well, let me tell you, it is interesting. Anyways, and a few things about partial sums. And you do the same thing, but with the reciprocals of numbers, you get 1 minus half plus 1/3 minus a quarter plus 1/5 minus dot. Then you get, surprise, surprise, one of my favorite constants, ln 2. And there's another series for ln 2. I mentioned it frequently in my videos because I just love this series. As you can see, this series is much faster, and I could calculate 16 terms of this series by hand and yet get ln 2 to 5 decimal places. So there, I hope you like this little short video about partial sums, reciprocals, and logarithms. As you can see, logarithms are very unusual connection in mathematics, but you don't do it alternating sum, but you do it with the reciprocals. You have infinity. There's proof of this, and you're going to find it out. But you do it with the reciprocals of squares, you get pi squared over 6. And you do it with powers of 3, you get what's known as Apéri's constant, or zeta 3, approximately equal to 1.202. You do it with powers of 4, you will have pi to the power of 4 over 90. If you do it with the number raised to its own power, like this, it's called the FZ sequence in an obscure field of mathematics called googology. And this has a very interesting integral. So we have this sum here. This is actually this. Let me just warn you that this is an example of a property faced by, I don't know who it's called, and it's called the sophomor's dream. It's too good to be true. It actually feels too good to be true, but it is. So there, I hope you like this partial sum, some reciprocals, some sums, and even the sophomor's dream. Well, in your sophomore, you could easily understand this, but summations don't easily equal integrals, and that's all I want to say. Goodbye.